In February 2022, Ukraine was estimated to have a mere fifth of Russia's total active military manpower. That's only around 20% of the number of military vehicles Russia possesses, 10% of its air force, and 10% of the overall national defense budget. And if that wasn't enough, Russia had at least double the number of infantry deployed near the front line at the start of the war, compared to Ukraine's limited defense forces. By all accounts, Russia had an overwhelming advantage. And yet, time and time again, Russia has failed to occupy Ukraine. In fact, they've suffered a series of losses that began in the early months of the war and continues right up till today. And it's only recently that Russia has managed to consolidate its gains a bit and push deeper into Donetsk. So what happened to the vaunted Russian military might? The might they flaunted in military parade after military parade. The weak showing is quite easily explained when you think about it. Russian weapons can't match their Western counterparts. So why exactly do Russian weapons fail when compared to Western ones? We'll cover a broad range of military equipment from land vehicles to aircraft to standard-issue rifles to determine just that. While both Russia and Ukraine started the war by largely using Soviet-era military equipment and their subsequent upgrades, Ukraine has been on the receiving end of round after round of Western munitions donations. The Ukrainian military has been sent much-needed modern weaponry and equipment, and has used it all to the utmost effect to stall the Russian invasion for far longer than any strategist thought possible. Let's start with Russian tanks. Arguably, the main battle tank of the Russian military is the T-90, but it could be said that the entire line of Soviet-era T-tanks, including the T-64, T-72, T-80, and T-90, form a contiguous line of technological improvements since the Soviet era, which used the T-64 as the main battle tank in the 1960s. However, most of the tanks relied on similar metrics, tactics, and military doctrine during production. Therefore, it's safe to say that they share in their inadequacy compared to Western designs. The T-90 and its slightly more modern derivative, the T-90M, are not the first tanks that Russia used when the invasion started. That honor probably goes to its older cousins, the T-80s and T-72s. This was due to a false belief that Ukraine lacked the ability to repel even the older Russian designs. In Russia's mind, since the stockpile of T-80s and T-72s was so high, and the tanks were relatively cheap to make and repair, their more disposable vehicles were good enough, just as long as they had working parts. The belief was they'd be on par with whatever Ukraine could throw back at them. But just a few months into the war, it was clear that the T-72s and T-80s were practically no match for the Ukrainian defenses. Russia started losing hundreds of tanks each month. The reason? These tanks weren't exactly designed to be used the way Russia utilized them throughout the war. The T-72 was based on the T-64. The T-62 was a tank developed after World War II, when the Soviet Union was trying to find the best way to counter the threat of US tanks. To that end, the T-62 utilized anti-armor ammunition, the piercing fin-stabilized discarding sabot round, whose sole job was to penetrate through the armor of the era, disable enemy vehicles, or inflict heavy damage on fortified positions. To its credit, the T-62 was a solid attempt at creating a tank that did just that, but its cannon proved to be unreliable and short, meaning that the tank wasn't particularly effective at a range. The T-64 attempted to remedy that by improving the cannon, but the Soviets slightly over-engineered the tank, putting in too many small parts and mechanical improvements. This went directly counter to the prevailing notion at the time that quantity was a quality of its own. The T-64 was an excellent main battle tank for its time, but the labor-intensive repairs and maintenance made it significantly more expensive to field in large numbers than its predecessors. Thus, the T-72 was mainly designed to bridge that problem. By reducing the mechanical complexity of the tank while retaining the armor-piercing capability, the T-72 could be mass-manufactured at a fraction of the price of its Western counterparts, or the T-64 itself. This meant that it would rapidly take over the T-64 as the main battle tank of choice for the Russian army, and became the template for future tanks. Unfortunately, that's precisely part of the problem. You see, one of the additions that the T-64 introduced was an autoloader, a mechanism that automatically swapped a used round with a fresh one from the tank's internal stockpile. The presence of the autoloader meant that Russian tanks didn't need a soldier to load the tank, which allowed them to reduce the size of the tank hull to load more defenses and mechanisms. On paper, the autoloader also heavily shortened the tank's downtime, which was once again the core of the Soviet quantity is quality belief. In reality, however, the autoloader has been a huge risk in the war. The loader systems store the spare ammunition inside the turret and next to the crew. In older tanks, such as the T-72 and T-80, there's no reinforced armor in the turret area. Thus, the turret is particularly susceptible to armor-piercing rounds or explosive charges. If one such ordnance penetrates the turret and detonates, it can cause a chain reaction of explosions of unused ammunition, leading to the entire turret exploding. Western tanks avoid this issue by implementing fail-safe hatches and venting systems so that the blast goes out of the turret and the tank sheds the excess ammunition. T-90s solve this in a way by carrying less ammunition, implementing slightly better turret protection. However, the tactics in the war in Ukraine were vastly different from what the tanks were designed to handle. Instead of trying to survive human-mounted anti-tank missile launches like the Javelin, Ukraine has used drones carrying bombs to devastate Russian tanks from above. While the former only has a relatively small chance of triggering a catastrophic loader failure, the latter significantly raises the odds. Furthermore, the autoloader system itself has been scrutinized, with reports showing that it's prone to failure, which renders the tank's main armament inert. The combination of a lackluster system with the fact that it can't survive modern armor-piercing ammunition is what makes Russian tanks behind the curve compared to Western ones. And Ukraine's drone warfare has rendered Russian forays into newer tanks equally obsolete. The proposed successor of the T-90, called the T-14 Armata, has been on display in Russian convoys since 2022. In 2024, they were deployed to the front lines, all 14 that were built at the time. But only 3 weeks later, all the tanks were recalled. The reason? Despite the tanks having marginally better defenses against drone warfare tactics, their price tag, which is several times higher than T-72s, means that potentially losing a tank to a drone strike puts the Russian military significantly behind more than usual. Add to that the fact that Russia can't easily manufacture spare parts or repair newer tanks, and it's clear why it still relies on inadequate Soviet-era stock. Next up, it's another armored vehicle, the Russian BMP, which is an abbreviation of the Russian term meaning infantry combat vehicle. The BMP, or more specifically the BMP-3, is one of Russia's only infantry support vehicle options that currently exist in its forces. The first iteration of the BMP entered service back in 1966, when it was immediately found to be lackluster at best. The hallmarks of the infantry support vehicle were the supposed amphibious handling, a relatively large troop capacity, and a decent armament that could provide cover fire. However, all of these aspects failed in one way or another. First, troop capacity came at a sacrifice of modern protective armor, even at a time when anti-tank rounds were much less effective than today. This was due to the BMP's relatively short profile compared to other infantry support vehicles. The Soviets believed that their vehicles could be used to ferry soldiers closer to the battlefronts, where they would only encounter 50-caliber machine guns or other infantry weapons, with practically no chance of meaningful anti-tank capacities. But by the time the Soviets actually fought in open conflicts, anti-tank mines and human-mounted launchers became so commonplace they could be obtained by guerrilla forces. With a severe lack of armor, the BMP was often referred to as the infantry graveyard, as a single explosive or armor-piercing ordnance that hit the vehicle could kill everyone inside. This fault hasn't been rectified in either the BMP-2 or BMP-3. While the specifics of the armor did improve somewhat, it failed to keep up with the advancements of Western armaments. The vehicle's amphibious capability has also been brought into question. This was due to the vehicle being much slower and more difficult to maneuver in water, despite its apparent floatability. Moving into a body of water where the vehicle floated essentially made it a sitting duck, unable to respond to enemy movement or fire. Until recently, most Western forces abandoned ambitions of using their infantry support vehicles for amphibious missions precisely for that reason. The most recent iteration of the US-made Bradley can also swim, but it's also taller and heavier, with a much better armor rating. This makes the vehicle much safer in terms of being able to survive or shrug off enemy fire. Finally, the BMP's armament has also been problematic since its very beginnings. The BMP-1 had a very constricted range of vertical turret movement, which housed a 73mm semi-automatic gun. This meant it couldn't be angled up from the horizon. In battles that took place in flat lands, this wasn't much of an issue. However, as soon as the BMP entered an area where they had to fight from low ground, they sometimes failed to be able to retaliate at all. The BMP-2 slightly amended the issue by giving the turret more mobility, changing it to a 30mm autocannon. This was paradoxically reduced for the BMP-3, probably due to the inclusion of a secondary 100mm missile launcher next to the main armament. But what has made BMPs so bad compared to their Western counterparts is their obsolete optical systems. The BMP-3 only has limited night and low vision capabilities, with no thermal imaging options, which all exist on the Bradley. In an ironic twist, the vehicle's systems create significant infrared output that can be picked up by enemy thermal vision. In a fight between a Bradley versus a BMP, the former will be able to spot its target and open fire much sooner. This has happened multiple times during the war in Ukraine, with reports and video records showing Bradleys firing upon BMPs who would then scramble for cover before trying to return fire. Russia has lost well above half of its 4,000 BMPs throughout all three versions combined over the previous 35 months of the war. The scale of losses proves that despite the 30mm autocannon and the 100mm launcher being potentially deadly weapons, they won't be of any use if the enemy starts firing first. Let's move on to the Russian Air Forces. More specifically, Russia's inability to leverage its fighter jets and drones to create air superiority over the Ukrainian skies. We need to preface this by pointing out that two of Russia's most advanced fighter jets, the Su-35 and the Su-57, actually compare favorably to their Western counterparts, the F-16 and F-35. In fact, the F-16 and Su-35 have more similarities than differences, both being highly maneuverable, dogfighting-oriented craft. However, the Su-35s have a longer engagement range, with a far more powerful radar that can detect incoming aircraft or lock onto targets from farther away than its Western counterpart. However, in actual combat scenarios, F-16s and Su-35s haven't really fought against one another. Both Russia and Ukraine have used their fighter jets to launch long-range strikes into each other's territory, with both aircraft practically never entering the opponent's airspace. This is due to both Russia and Ukraine having significant anti-air defense capabilities, making any direct mission incredibly risky for the aircraft involved. But the F-16s do have some tricks up their sleeve, namely more modern electronic systems that allow them to uplink data to other aircraft or to ground control from farther away. This allows the aircraft to be used more effectively to scout and detect enemy movement or positions. Furthermore, the F-16s don't have any maneuverability issues when flying low to the ground, potentially allowing them to fly below Su-35 radar ranges and conduct covert strikes. The F-35 and the Su-57 are also more or less evenly matched in terms of armaments, engagement ranges, operational ranges, and maneuverability. That being said, the Su-57 is woefully ill-equipped in the stealth and avionics department. The F-35 can often shrug off detection attempts with more modern electronic and design countermeasures to radar. This makes it possible for the US plane to go farther into enemy territory or engage with the enemy at a far more favorable position. But where the Russian Air Force truly starts losing in pretty much every regard is bombers. The Russian stealth bomber project, the Tupolev PAK-DA, is a long-anticipated addition to Russia's Air Force arsenal. The stealth bomber is supposed to have superior stealth technology, comparable to that of the B-21 Raiders that have just started flight testing. This, coupled with the 30 tons of supersonic missiles that the PAK-DA can carry, more than the B-2's capacity, should have provided Russia with an opportunity to bomb Ukraine from a distance with minimal repercussions. However, the PAK-DA project never really took off. The initial designs for the bomber started back in 2007, facing numerous engine issues that supposedly repeatedly delayed the 2023 unveiling. This meant that the project, which has been 17 years in the making, is relying on technology that's not kept up. The current timeline for PAK-DA production doesn't begin until 2027, putting it at least 4 years behind the US for future generation bomber options. In those 4 years, the US would have likely already started producing the B-21s and amassing a solid arsenal. Furthermore, with Russia's ongoing issues in the war, chances are progress on the development has stalled even more. At this rate, the bomber might not ever take off, both literally and figuratively. This leaves Russia with rapidly obsoleting bombers compared to the US, which is already beginning to upgrade its own, putting Russia even further behind the curve. In a similar vein, Russia doesn't produce long-range drones, at least not yet. The most common long-range drones were the Shahed 136s imported from Iran, which had limited success against Ukraine's improved anti-air defenses. Russia did plan to create a more modern drone that will be more similar to the MQ-9 Reaper than the Shahed 136, named S-70. This proposed drone was first unveiled in 2019 and officially entered service in 2020. The S-70 supposedly has the capability to carry multiple munitions and deploy them simultaneously, all with a 3,600-mile operational range. However, the first tests of the drone in real-life combat scenarios were catastrophic. The drone lost contact with ground control, quickly swerving off course and failing to engage its weapons. The Su-57 that was carrying the drone was forced to shoot it down to prevent the drone from dropping in Ukrainian territory, which also failed, causing the drone to be recovered by Ukrainian forces. It was discovered that the drone doesn't actually have much in terms of independent flight ability, relying on gliding to carry itself from the deployed plane to the target. This also means the drone is practically single-use, as it can't turn back and return to the operational center, or at least not easily. The drone's autonomous systems have also been criticized, as a modern UAV should have some fail-safes in place when it loses contact with control. After all, the price of an S-70 is expected to be in the hundreds of millions, far above that of a kamikaze drone like the Shahed 136. Russia's anti-air systems are in similarly bad shape. Russia uses 3 versions of a similar anti-air battery: the S-300, the S-400, and the S-500. The S-300 is mainly relegated to export, where a downgraded system is being sold to countries such as Iran, with mixed results, as recent bombings by the US and Israeli forces would suggest. The S-400 is the country's hallmark anti-air system, with several batteries stationed in Crimea and territories around Ukraine. However, the S-400s have proven to be unreliable. Ukraine has used ATACMS missiles donated by the US to destroy at least 2 S-400 batteries in Crimea or Russian-occupied areas of Ukraine. This means that Russia's modern systems, developed in the late 2000s, can't counter missiles that were first developed in 1986. The explanation posited by Western media implies that the S-400 has difficulties with ballistic systems, whether due to radar malfunctions, disabling, or lack of preparedness. Compare this to the US counterpart, the Patriot, which has been massively successful at intercepting Russian missiles. In fact, Ukraine has lost just 2 of its Patriot batteries despite being heavily numerically disadvantaged. One of the ways Ukraine has likely beat the system is by selectively dismantling its support structures. By targeting other defensive weapons that the S-400s were meant to defend, it's likely that Ukrainian electronic warfare systems have managed to disable the layered anti-air system that should have detected missile strikes in the first place. This points to the possibility that the S-400s can become increasingly vulnerable to electronic warfare, making them far less impressive than their specs would suggest. But with all these large systems failing, Russia can always rely on outfitting its numerically larger army and infantry with higher-grade weapons to take Ukraine on foot, right? Well, no. The standard issue rifle for the Russian forces since 2019 has been the AK-12, an upgrade over the previous AK-72. But the scale of upgrades seems to be much worse than it should have been. The AK-12 started its testing all the way back in 2012, when it was determined that the AK-72 was approaching obsolescence by modernized US rifles. To solve that issue, the AK-12 was proposed, with a much more balanced automatic action compared to its predecessor. The initial tests of the rifle, however, proved that this would be far from the truth. The AK-12 repeatedly failed to meet state requirements. Further attempts to improve the rifle to fulfill these standards resulted in the cost of the gun skyrocketing, making it prohibitively expensive for mass adoption. Instead, the gun was changed repeatedly between the first showcase in 2012 and its eventual final reveal in 2018, to the point where the final only had roughly 10% of the parts of the prototype. In the end, the AK-12 would end up rolling back many of the proposed changes and stuck with using the core of the guns that were developed all the way back in the 1940s, including the famous AK-47. The gun's upgrades only marginally improved its reliability and combat efficiency, but they are still overall better than the AK-72 it was meant to replace. This showcased that the Russian rifle industry is practically incapable of creating novel designs, falling back to the same options time and again, hoping that small upgrades will eventually yield some results. The same sentiment could be applied to Russia's entire military system in a way. Russia started the war in Ukraine with a disastrous first strike while trying to take over the airport in Kyiv. This tactic previously worked in Poland and even Crimea, but this time the Ukrainians were ready. Faced with a sudden change in tactics, the Russian military failed to adapt to the possibility that they wouldn't be able to steamroll through Ukraine in mere weeks. And this failure is shared throughout Russia's systems: the tanks, the aircraft, and the anti-air defenses. Russia always thinks that its systems are better than those Ukraine can field through its NATO donations, and yet Ukraine has managed to make a fool out of the Russian military at every turn. At one point, Russia was considered to have the world's second-best military, but like the state of Russian weaponry, this has been debunked. Faced with economic turmoil, Russia won't even have an option to improve its weapons much during the war either, because even if you funnel money into development, if your core belief is that you're doing everything better than the opposition doesn't change, there won't be any progress. But what do you think? Will Russia's failing weapon system finally allow Ukraine to win the war? And how much longer will the war go on for? Thank you for watching, and leave your comments below. Now go and check out why Russia's navy sucks, or click this other video instead.